we are going to learn another way to solve our systems of equations. And this is called with a matrix. So it's usually I would say the least common one that's taught when you're in high school. Sometimes you learn about them, sometimes you don't. I never did. I didn't learn about them until college. It's just kind of what your school covers or doesn't. So a matrix is a rectangular array of numbers written within brackets. Okay, so for example, I'm going to give you, matrix A is 1, 4, 7, 2, -1, 0. And if you want, I can let me add a little bit of space between those just so it actually looks separate. So 1, 4, 7, 2, -1, 0. Okay, I'll give you another one. An example B is 1, 2, and then 3, 1. So A is a rectangle. You can actually see it looks rectangular. The numbers that are in the rows and the numbers that are in the columns is different. B is called a square matrix because we have the same number of numbers across and horizontal. So, this is called a square. I can also have a column matrix. So it's just numbers in a column like this, 1, 0, 3. Or I could have numbers written in a row like -3, 4, and 10. So matrices come in all shapes and sizes. And that size that they come in is called their dimensions. So the dimensions are always going to be rows by columns. I spelled it wrong again. M-N-S. Okay. So A has 2 rows by 3 columns. So that would be called a 2 by 3 matrix. B, 2 numbers across the rows, 2 separate columns. So it's a 2 by 2. C has 3 rows by 1 column. And this one is 1 row by 3 columns. So depending on how your numbers are arranged in your matrix, that is the dimensions of your matrix. And then clearly it should make sense. 2 times 3 means there should be 6 numbers inside my matrix. There are 6 numbers there. Now, each number is an element, and each element then has a position. So the way you label an element is like this: A, and they say I, J. So I is representative of the row. J represents the column position that the number is in. So if I work with matrix A, the element in A, let's say 1, 2. Okay, so that's the first row, second column. So if I look at this first row, the second column, that is number 4. okay? Or the element, let's say A, 3, 2. Not 3, 2. Other way around. I wanted 2, 3. Sorry. Okay, stands for second row, third column. What number is in the second row, third column? 0. Make sense? A12. A12 means row 1, column 2. Row 1. So this is row 1, this is row 2. Column 1, column 2, column 3. So row 1, column 2 is right here. So this would be 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. And then there's another row, 3, 1, 3, 2, 3, 3.
Gotcha.
All right. So, I guess I put that on the previous slide. All right. So what we're going to do is we're going to use a matrix to solve this by hand. Basically, what it does is it lets us work solely with the numbers and not worry about having an X or a Y or any other letter in the problem. You're just solely working with the numbers. Okay, so the way we do this is we're going to make what's called an augmented matrix. So what you're going to do is we're just going to put the coefficients. So it's 2, -1, and -7. Second equation, a 1 is in front of the X, a 2 is in front of the Y, and the 4 is the answer over here. So I call this an augmented matrix because what's happening here is you've got your first column is your X, your second column is your Y, and then what's on the far right-hand side is your solutions or your final answer. So augmented means you draw that vertical line right where your equal sign would be, and that's going to separate your variable pieces from the solutions. Okay. Our goal is to get something that looks like this. 1, 0, and a number. 0, 1, and another number. That's our goal. Because that's going to give us our solution. That's going to tell us X equals whatever this first value is, and then Y equals this. Because this is the X value, this is the Y value, this is your solution. So if X is 1, 1X, no Y's, X equals this answer over here. So there's an order to this process that we follow. The first step is to turn the upper left corner into a 1. Now we actually have two choices here. I can turn this 2 into a 1, or I can see that there's actually a 1 below it. And I have an option. It's not going to change anything if I just flip-flop the order of these rows. I'm still working with the same two equations. So the first step is to get this guy to be a 1. So I'm just going to, as my first step, flip-flop row 2 and row 1. So this notation on the side here is just telling myself I am switching places of row 2 and row 1. So I'm going to rewrite it as 1, 2, 4 to -1, -7. Okay, step number 2. I'm gonna try to keep these, try to color code it correctly here. Okay, so step number 2 is to turn to get that 0 there. So underneath your 1 should be zeros. Now, the way we get that is with a form of elimination. Okay, so our goal is we're doing basically elimination, but not writing the x's and the y's there. So if I need to turn a 2 into a 0, and I was doing this with elimination, thinking of this as 1x over 2x, I would multiply the top row by -2, right? Because the -2x and plus 2x would cancel out, right? If we were doing elimination, 1x plus 2y equals 4, 2x minus 1y equals -7. If I multiply the top row by -2, -2x minus 4y equals -8, stack it with 2x minus 1y equals -7, and then eliminate, do my x's disappear? Yes. So what I'm doing is elimination without writing all of this out. Now I'm going to write it out so you can follow the process for right now, but eventually don't have to. Okay, so what I'm doing here for elimination is I'm going to take -2 times that first equation, add it to the second equation, and that's going to go in the second line. So here's what I like to do. I will color code what stayed as it was. I didn't touch, in the end, I'm not changing the first row. My goal is to get rid of the 2 that's down here by multiplying the first by -2. So this is the math over here that we're actually doing. And then adding. So -2 plus 2 is 0, no x's. -4 plus -1 is -5. And then -8 plus -7 is -15. So I'm literally just putting those coefficients over here. New color. Next is to get the next one. So step 3 is this one here to get your 1. Now, it's easier to get 1s. To get 1s, you're either going to, goodness gracious, swap rows or divide or multiply. So what I want to do is I want this guy now to turn into a 1. So if I were to work with this and I were to solve it, what would I do over here if I was actually solving this equation? Divide by what kind of 5? -5. I would be dividing by -5. That's exactly what I'm going to do over here. I'm just going to write it in matrix form. So I'm going to take row 2 and divide by -5. Okay, I'm keeping the top row as is. So this top row hasn't changed. 1, 2, 4. I'm only changing the bottom row. So that's going to give me -5 divided by -5 is 1. -15 divided by -5 is 3. And would you agree that if I solve this, y is 3 over here? And that's exactly what this matrix is now showing me, is that y is 3. Okay, so my last step here is to then get my 0. Now, zeros involve using this elimination tactic. Okay, so zeros I get using elimination. So you're going to multiply something to a row and then add it to the other row so that you're going to cancel out that value. Okay, so if I was working with, just to show you here, 1x plus 2y equals 4 and 1y equals 3. And we want to cancel out the y's. What would you have to do? Times this one down here by -2. Yep. And then I would be able to add my rows together. That's exactly what we're going to do in the matrix. So I'm going to take -2 times the second row. I'm going to add it to the first row. Now, this second row is solved. Our goal is to solve for x. So it's going to replace the first row. Because our goal is we are changing something in the top row's position. Our goal is to get a 0 here. So I have 0, 1, 3. That part is not changing. Okay, so if I did the math out here, 1x plus 2y equals 4. -2y, -6. Okay, so 1 plus nothing is still 1. 2 minus 2 is 0. 4 minus 6 is -2. Once I get to this form, I am done. And that's step 4, not step 3. So our final solution here says x is -2, y is 3, so -2, comma 3. And I am recording this as well, so you can always go back and look at it. Okay.
Question. So with elimination, most likely do the math, but when I'm getting to when you wouldn't have.
You don't have to do this. Like I mentally on the side am doing. So rather than writing all of this out, what my brain is doing here is saying, okay, I'm going back here. -2 times 1 is -2, plus 2 is 0. -2 times row 1. So -2 times 2, -4, plus -1 is -5. So I'm just showing the long process of how I'm getting this over here, just so you can see, one, how it relates to something we've already done, and you can understand where the numbers are coming from before I'm just sitting here going like, let's just write some numbers down with no context of where we got them. I mean, graphing is always going to be the fastest. 100% graphing is fastest. If you have to do by hand, elimination for me is always easier than matrices. But the problem becomes that once you add extra variables, so once you get to like a 3x3 or something larger, you don't want to keep working with the x's and the y's and the z. Like if I had w, x, y, and z, like I wouldn't want to keep writing all of that. Writing all of the extra letters becomes cumbersome, and it's a lot more room for error than if you've mastered this. All right. Now, I'm going to show you a really cool shortcut. We are going to do one more by hand in a little bit here, or 1 or 2 more by hand. But I also know that in life, in your job, you're not going to solve any matrix by hand, right? There's no reason to. Why would I spend 20 minutes to solve a matrix by hand if I know I have technology that can solve that for me, right? And that I can get the answer and I can use the answer and then do with the process what I need to do. So What I like to do is I use Desmos for this class just because it's free to everybody. Not everybody has like a TI-84 calculator. So in Blackboard, under our folder for this week, so it's in the second folder, the second one, the week 2. No, it's not in there. Where did I put it? Oh, I'm sorry. It's in week 3. So it's in week 3's. It's the first link. It says Desmos matrix calculator. Maybe? Okay, right here. Yep, Desmos matrix calculator. So I'm going to click that guy. All right. This is awesome in that it gives me an answer quickly. So what I'm going to do is I'm going to type, I will have a new matrix. You are going to, this is a matrix, right? 3, -2, 6, 4, -3, 6. I'm going to enter that matrix into my calculator. Now, if you look right now, my matrix is set up as 2 by 2, but I need 3 columns. So I'm going to add a column here, and now it matches. Oh, don't see that. All right, so then I'm just going to do 3, tab, -2, tab, 6, tab, 4, tab, -3, tab, 6. Oh, so that's my matrix. The process that we just did was called reduce row echelon form. We put the matrix in reduced row echelon form. That is one is down the columns, or sorry, one's down the diagonal. Apologize, I'm literally doing this and saying the wrong word. Diagonal, zeros everywhere else. So what I can do here is I can hit RREF of matrix A. It's right down here on the very bottom. Did you hit enter?
Okay.
For your matrix A, because matrix A should be in there first.
Yeah, we do.
Okay, so this is going to do all the math for you to show you what the final answer is. So could you practice and say, okay, I want to see, can I do a few of these steps? Could I practice by hand and then double check it here? Yes. Okay. So this one's answer is X is 6, Y is 6. Okay, so this is reduced row. Let me write the actual word out. Reduced row echelon form. So what this is actually doing is we've created what is called an identity matrix on the left-hand side. The identity matrix is solely comprised of ones and zeros, 1 on the diagonal, 0 is everywhere else, so that we can then have our solutions on the right-hand side here. Right? So if I were to just show you, this is x1 plus 0 x2s equals 6, right? No x2s means it's not there, means x1 is 6. That's how I'm getting the answer from this matrix. Now, we know we have 3 potential solutions when we work with systems of equations. We know we can get a solution. So option 1, we get a solution, 1, 0, 0, 1, and then these numbers over here. Okay. If we reduce our matrix, and it looks like this, 1, a number m, a number n, and a whole row of zeros. The whole second equation disappears. Means that we have a multiple of the first equation. This is infinite solutions. I clearly am not spelling today. Okay, if the top row looks just the same as the last one, however, the bottom row says 0, 0, and some other number p. Okay, so m, n, and p, these are all representative of a number. Okay, when I read this last row, this is saying if I plug in 0 for x and 0 for y, I somehow magically get some answer, such as like 5. Is it possible to make 0 plus 0 equal 5? No. So when I look at this, this is saying 0 equals p, but p is an actual number, not 0. Not 0. So this can't happen. This is a false statement, so we have no solution. Okay, so let's do another one by hand, and then we'll practice more with the calculator. Okay? Here. All right, so I have negative 2x plus 6y equals 6. 3x minus 9y equals negative 9. So I'm going to put negative 2, 6, 6, 3, negative 9, and negative 9. Okay, and your steps are always, this is step 1 to get a 1 up here. Step 2 is to get the 0 there. Step 3 is to get the 1 next to it, and step 4 is to get the 0 above it. And the rule is if you're trying to get a 1, you're going to multiply or divide to turn that value into a 1. So I currently have a negative 2 here. Would I need to multiply or divide by something to turn that into a 1? Divide by what? What kind of 2? It has to be a negative because a negative divided by a negative is going to give me that positive that I want. So I'm going to take that first row and divide everything through by negative 2. So all I'm doing is changing the first row here. So that becomes 1. 6 divided by negative 2 is negative 3 and another negative 3. This is, again, also why I like to use colors so that I can distinguish between what I've done and what stays the same. So if I don't change it, it will stay the same color as it was in the previous step. All right, so step 2 is to turn what's underneath the 1 to a 0. The way you do that is with an elimination. So what do I need to multiply 1 by that if I add it to 3 cancels it out? So I'm asking myself, what do I multiply 1 by when added to 3 cancels? Well, if I multiply by 3, 3 plus 3, that doesn't cancel. So it's not 3, it's negative 3. So I'm going to take row 1 times by negative 3, and then I'm going to add it to row 2. Now, our goal is to get a 0 in row 2's spot, so that's where I'm putting it. So put it in row 2. So you're always adjusting the first row, then the second row, then the first row. It's always in that order. So it'll always be replace the first row, replace the second row, replace the second row, replace the first row. It's always going to go in that order. Row 2, row 2, row 1. All right, so let me rewrite my top row. That's not changing. Okay, so let's just on the side do some of the math. So row 1 value times -3. So I take 1 times -3, and then I'm going to add it to the value below it, 3. 1 times -3 is -3. -3 plus 3 is 0. Okay, do the next column. So row 1 value is -3. I'm going to times it by -3 and then add it to -9. I'm literally just following this equation with each column. So row 1 is 1, row 2 is 3. I just plugged it in. I'm going to do it again with the next column. Row 1 is -3, row 2 is -9. Just plugging it into what I wrote here. So -3 times -3 is 9 plus -9 cancels out. And that column is exactly the same. So what happened? I got full row of zeros. Which one is it? Infinite solutions right there. Do you have to memorize that? No. Anytime you're doing your homework or a quick check or a test, do you have access to your notes? Yes. So you can always look back and say, oh, shoot, is that infinite or no solution? I don't remember. Let me look it back up. I am struggling today. Solutions. Now, technically, what I need to do is, this isn't the best mathematical answer that I could write, okay? So what I'm going to do is I'm at this point where it says, if I take this, x minus 3y equals -3. So I could solve this equation for x, right? If I solve it for x, I would add 3y to the other side. So x equals -3 plus 3y. So that means my x coordinate is -3 plus 3y. X was written in terms of y, so then y is just y. So what it does is, rather than just saying there's infinite solutions, I've now created a way to determine all of those solutions. So what you do is you solve one of your variables, solve for one of the variables, whichever one's easier, and then you put that for its spot. It's always x comma y, right? So instead of x, I'm writing -3 plus 3y, and then it's comma y. So what does that do? Well, that tells me that if I plugged in a y of, let's say, 1, if I plug that in there, -3 plus 3 would be 0. One solution would be 0, 1. I could pick another number for y. What if I picked 5? 3 times 5 is 15. 15 plus -3, 12. 12, 5 is another solution to that problem. So this is just telling me how I can determine all of those solutions. Does that make sense? All right. Let's do this one actually by Desmos. So we have 2x1 minus x2 equals 3, and 4x1 minus 2x2 equals -1. So we have 2, -1, 3, 4, -2, -1. There's my matrix, right? Where did I write it? There it is. Okay, so I'm going to do a new matrix. One thing to note as I'm doing this here. Give me a second because it'll pop up and let me enter it first and then I can show you. 2, -1, 3, 4, -2, -1. All right. This calculator will store 8 matrices and it will go in order. You will do A, then it'll do B, all the way through H. So if you keep using this calculator past 8 problems and 8 matrices, what you're going to have to do is just hit clear all, and then it clears everything and restarts with you have now 8 matrices to work with. Okay? So you always need to look at what letter is in front, because I want to reduce row echelon form, now matrix B. Okay. So here I did this. One really nice thing about the Desmos calculator is that if I ever get a decimal, you see how this little fraction button popped up here? I can click this and it converts it to a fraction for me. So I can automatically see what that decimal is in fraction form. All right, so when I reduced it, RREF, we got 1, -1/2, 0, 0, 0, 1. So that bottom row is telling me no x's plus no y's equals 1. Not possible, so no solution. Okay, got one more by hand. And then we are done with examples for the day. I'm going to give you guys one to practice. I'm going to have you try it by hand. The challenge is to try it by hand. I am not going to mark you right or wrong if your by hand work is wrong. Okay, I just want you to try it. I want you to try it and then double check it with Desmos when you're done. All right, so we got 3x minus y equals 7, 2x plus 3y equals 1. So that is 3, -1, 7, 2, 3, 1. Just to give you an idea, the Pearson homework may ask you to do like one step of a solve. It'll say like, take 2 times row 3. What does it give you? Or it may have you do the one step where you turn something into a 0. It's never going to ask you to solve the entire thing by hand. I am never going to ask you to solve an entire one by hand. But I'd like you to attempt it today as a challenge, practice, yes. On a quiz or test, are you going to be able to use Desmos? Yes. Okay. So just going to put that out there. But it's a good thing to understand and practice. All right. So goal is first step. Row 1, we need a 1 in this upper spot. So what am I going to do to turn that 3 into a 1? Divide by 3. So row 1, divide by 3. Replace row 1. Okay. I should probably pick a different color here to write this. Divide by 3, replace row 1. So 3 divided by 3 is 1. All right, this is going to make -1/3. At times, we get fractions. 7/3. To get a 1, you divide. Divide or multiply. Always divide or multiply. So I have 1, -1/3, and 7/3. All right, so next step is to get a row 2 value to be a 0. The way we get a 0 is by multiplying by the opposite. So if this is 2, I'm going to multiply by -2. So -2 times row 1 added to row 2, replace row 2. So top row, I am not touching. Okay, you can default put a 0 here. That was the goal. By doing this, I was going to get a 0 there. All right, so now I have -2. I'm going to look at this column and plug it in. So -2 times a -3 plus 3. Okay, so what is that? 2/3 plus 3. That's 3 2/3. I'm going to make it an improper. What is that? 9, 10, 11 thirds. Just because it'll be a little easier to work with in the next step. Okay, next one, -2 times 7/3, and then add 1. What is that? -14 thirds plus 1. So I'm adding, what is that? 3 thirds. So -14 plus 3, -11 thirds. After this next step, it'll turn a lot better. I promise. Okay, so next one is to turn this guy down here into a 1. I'm going to multiply or divide. What am I doing to turn 11 thirds into a 1? Divide by 11 thirds, but instead of dividing by a fraction, we usually multiply by the reciprocal. Reverse reciprocal. I knew what you were going for. Okay, so instead of saying row 2 divided by 11 thirds, we're going to say row 2 times the reciprocal 3/11. So look at here. If I take 11 over 3 times 3 over 11, the 3's cancel, the 11's cancel. I'm just left with 1, correct? 0, 1. And then if I have a -11 thirds times 3 over 11, I'm just going to get -1. Not touching that top row. 0, -3, and 7 thirds. Okay. Last step is to turn this into a, oh my goodness, hold on, that's a 1, not a 0. Turn this into the 0. So I'm going to multiply by the opposite. So I'm going to multiply by positive a third. So row 2 times positive a third added to row 1. And again, at this point, you're not doing a lot of math. Okay? I'm keeping this as 0, 1, -1. If I set this up right, then this should be 1, 0. And all I need to do is find this last one over here. So row 2 value is -1 times a third, add it to 7 thirds. So -a third plus 7 thirds. 7 minus 1 is 6 thirds. 6 divided by 3 is 2, -1. Okay. So your quick check today is another word problem. However, it's a table problem. So you need to, whoa, that is not what I wanted to do. you're going to need to turn the table into your equations based off of where your totals fall. So we did ones like this on Tuesday, where we put our totals and then we saw how we made our equations. Once I make my equations, set up your matrix. So you can see here, it says 2 points for your equations, 2 points that you've set up the correct matrix. I gave you 1 point for the answer. So you can see here, I'm not grading you on the work, but I would like you to attempt to solve it by hand. If you get stuck, ask, use Desmos, whatever you need to do. My goal is in the end, get the correct answer using Desmos. And then tell me in real world meaning, so in words, what does this answer tell me? What do I need to actually do? Okay, just like last time, if you want to do it if you're doing it on paper, you want to hand me the paper, that's fine. Just go in here, and when you click like start an attempt, to say submitted via paper, and you can hand me the paper. That is another option as well. Otherwise, you can, like I said, take your picture, upload it, type it, however you want to do it. But that is all I have for today. Your ear